Okay, I'm going to finish up problem 14 to swing real quick, physics friends. So let's just jump into it. Part 3, find the tension in the rope at the bottom of his arc. Okay, so we have this person swinging and they are coming down here and they're going to go through this bottom part. This is 3.0. 4 meters. As you've seen in the other parts 1 and 2 we talked about, he started from rest in a directly horizontal position, and so there we have it. We want to know what is the tension, so we want to know Ft here. So if we were to draw a free body diagram real quick, we can do that. We have Ft this way, and we have two forces to do here, centripetal force here, and we also have gravity. Okay, very similar to the last problem, but not nearly as hard actually. So Fg is equal to mass times acceleration due to gravity, and that is simply 72.2 times 9.81, and that's 708.282 newtons. Okay. The other part is Fc equals mass times centripetal acceleration. And for that we need V squared over R. We need the velocity at the bottom of the rope. Okay. We need energy. Well, you can use kinematics. At this point you could use kinematics. I'm going to use energy. So what was my potential energy at the top of this whole thing? Well, it's 3.04 is what this is going to be falling through. It's mgh. So the mass is 72.2. Gravity is 9.81. Excuse me. Height is 3.04. So now we do this and we get 2153.17 joules. Now all of that gets turned to kinetic energy. So we're going to put this in here for kinetic energy because it all got turned to that. 2153.17 equals 1/2 72.2, and solve there. Divide this, divide a half, divide 72, make sure you're using your own numbers, and then take the square root. And what we're left with, a velocity equals, running into room, velocity equals 7.723 meters per second. Awesome. Now we can fill in here and find, choose a different color. We can find the acceleration here, centripetal acceleration, and it's 7.723 squared, and this is r, so our length of our radius, and it is 3.04. And when we do this, we end up with that equal to 9.355, and our units will be meters per second squared. Now let's fill in here, and we got Fc, our centripetal acceleration is 72.2 times our acceleration, which is 9.355 that we just found. And we do that, we end up with did I not show that? Well, yeah. Oh, no. This is wrong. Whoops. My numbers are wrong. When I do this here, whoops. Sorry. Paper, I should learn to be a little more diligent. I did this problem yesterday on my own, and then I just didn't label everything, and it's everywhere, so bad, Mr. Hendershot, bad. Everything I say not to do, I did. Anyway, this is 19.62, so get my purple, 19.62, And then when we get in there and we multiply those two, we end up with 1416.56 newtons. So we now have our two forces, this one and this one. So this is 14 point, oh not point, 1416, okay, 0.56 newtons. And this one is 708. Let's just look at it right there, 708. And so this is equal to the sum of those two, because it's in static equilibrium in this direction here, because the ups will have to equal the downs, because it's not accelerating up or down. It is going right here in this direction, but it's not falling off its where it's attached. So it's the sum of those two, and when I add those two, I get 24.8 newtons. So you had to do these two added together. So Fg plus Fn gets you 24.8 newtons. So, and here it is in scientific notation. All right, awesome.